we move from challenge to solutions in practice. In the next blog, we will hear the project pitches. So what concrete technology this concrete technologies does, the energy savings, the cost, operations, and deployment. And first, we will hear from SteamDry's. We have Harri Kiiskinen, project coordinator and principal scientist at VTT Technical Research Center of Finland.
Thank you, Angela, for introduction, and thanks also, Sabrina, for telling the big picture and basic principles behind this technology. So I will today go a bit deeper, explaining what we are actually doing in here. The main goal was already introduced, so basically this energy savings and CO2, getting rid of CO2 emissions, that's our main target. When the project started, we estimated that we can achieve 60% energy savings in thermal drying, which equals roughly 40% savings on a paper making line. And currently the figures are actually higher, so we are really had a good progress, and today estimates I will go there shortly. And we are now in the pulp and paper sector, but basically this technology has a good replication potential, so it can be used elsewhere. For example, in wood processing, we have already worked a little bit with that. And for example, the food industry can really utilize this technology as well. And for this work, we have collected a consortium of 14 players from 7 different European countries. This is a research and innovation action, which started January 24, and we still have 1 more year to go. So the project will end in summer 2027. And then from the figure, you can see the industrial players and the research institutes. VTT is a coordinator of that, and then we have a let's say major machinery supplier Valmet from Finland, and pillar machinery supplier from Germany, and then research institutes, product manufacturers all over the Europe. And since it is research and innovation action, we started from technology readiness level of 4, and our target is achieve level of 6 when the project ends in a year. And what we are actually doing, so really how to implement the new technology. So we started really developing this pathway, what kind of steps there are and how this roadmap will look like. And then these technical challenges, there are basically 2 major ones. We really need to ensure that the steam quality is good. And the steam quality means 2 things. So we need really to, in order to achieve this high energy savings potential, we need to keep this air and steam separate. So if there is some air leakages into this steam system, it doesn't affect that much on drying rate, but it has a big effect on this heat recovery. So this sealing of that kind of a dryer is the first technical question we are working with. And the other one is that since the steam is in direct contact with the material to be dried, there might be some volatile components, some particles in that steam. So how to really clean the steam, and that is another technical question we are working with. And since this steam is a new type of, let's say, moisture carrier fluid for our dryer, so how to start this kind of system, how to operate. So this is a new control system, having digital twin, that's a big part of the project. And last but not least is really the piloting. So we want to show that this really works for in dynamic conditions, and that's what we are actually doing. We didn't need to start from scratch, so there was actually a bit more than 20 years already an EU project focusing on same technology. And from the image you can see something we built at that time, basically the first ever this kind of a dynamic wet dryer. And there were no any forming section or anything else. We just had some kind of a moist rolls, and we fed them through this kind of steam box. And we actually found that this energy savings potential is clearly there. We also found some positive quality changes, and most importantly, this drying rate. So there was no any information available, what is the drying rate for this kind of system, how fast it evaporates, and what happens to this quality. So those findings were really positive, but at the same time we identified these technical challenges, especially this sealing. And from this old image, you can also see a funny detail. So luckily, this technology development has done further, but also these working safety conditions are today a lot better. There are no any, let's say, personal safety gear, this person who is working there. Today, those things are luckily a lot better. So what we are doing now is that in the image, you can see actually our pilot line here at VTT in Jyväskylä, Finland. So these dryers on this image are gas-fired air impingement or true air dryers. We have basically replaced those and modified this dryer area of this pilot. And how it looks today is that we have this kind of a new superheated steam dryers there, 2 of them. And the whole process, this gas-fired system is gone. So now we have electrical superheaters and this superheated steam dryer boxes there, and also this kind of, let's say, sealing elements before the dryer and after the dryer. And these are actually the technical things we are focusing on. And this pilot was started something like a month ago. We had a consortium meeting or one of the big meetings here in Jyväskylä, and I'm happy to see a lot of happy people there. Even the first trial went really smoothly. And now we have something like 1 year to really tackle all these technical challenges and develop this technology further. And like Sabrina already told, so today there are basically all the cylinders are this kind of conductive ones. So paper is in contact with the steam heated cylinders, and then water is evaporated in air, and then this heat is recovered from that moist air. Basically, it is possible to put this kind of steam hood around the existing dryer. That is one concept we are calling a conductive. The other one is the one we have currently in this image is something called convective superheated steam dryer. We are basically impinging this steam against the web, which is there. And both have the, let's say, pros and cons. This has a really nice web support. Runnability is good, but it uses a bit more energy than the other one. This is the energy savings potential is clearly higher there, but the technical challenges are bigger. So what we have developed now is something we call a combined SSD, in where we are basically combining these two, so that we can start the drying with this convective thing and then actually utilize this produced steam in contact cylinders. When we compare this energy savings potential, investment, payback time, runnability, and how it is easy to retrofit the existing machines, we clearly see that this combined SSD is a winner compared to these 2 other concepts which are listed here. And this there are many, let's say, positive things why we have ended up in this one. So we can basically mostly use the existing dryer where this produced steam is fed and used, and then it also gives a higher drying capacity, so we can basically run a bit faster or put thicker threads, whatever is the need. It's built on this known impingement drying technology, which has been out there for more than 20 years. And then also this time to market estimate we currently have, it is somewhere around 5 years. And if we then take a bit closer look how this concept look like, so basically this is the combined SSD dryer. So we start the drying with the superheated steam dryer. It is right here, and then this steam, which is actually produced by this SSD dryer, is fed to this multi-cylinder dryer. And like I said, market entry estimate is somewhere around 5 years, energy savings potential somewhere around 40%. And then, of course, we know that most cylinder dryers are using this contact drying. So the big potential and big savings potential also is there in this contact drying. but build such a system for existing dryers. We call it steam hood. We have estimated, since there are a lot more technical challenges, it will take something like 10 years. But the energy savings potential is clearly higher. It can be somewhere around 80%. And since there are hundreds and hundreds of this kind of dryers, of course, that is, let's say, our next big goal after this steam dryer project have completed. And from our webpage, steamdry.eu, you can actually download this kind of vision roadmap, which is one of the public deliverables we created. And from there, you can find how we see it today. We are now in this SteamDry's project focusing on this technical question I just explained. Currently, we have actually started to build an innovation action next project in where we are targeting to put this technology on a Valmet pilot machine and really then run a real full speed, 1,000 meters per minute or even higher. And then, like something like 5 years from now, we are estimating that then this first rebuilds from these cylinder dryers could be on the market. So that was in a very short what we are doing in SteamDry. Thank you very much.